Good morning, students. Today we are going to touch on the topic of rational inequalities. What do I mean by rational inequalities? Rational numbers are numbers that can be expressed in the form of a fraction. So rational inequalities will be in the form of like f of x over g of x is greater than or equals to h of x over maybe p of x. Now, rational inequalities, there are fractions involved, all right? Something over something is greater than a whole number, or something over something is smaller than 0, or something over something is greater than a function over another function. So these are called rational inequalities. Now, before I do an example for you, let's look at the theory behind it. All right. Now let's say that this is a graph of f of x. Now the one in red, all right, the vertical line in red is the vertical asymptote. So you have the roots here. All right, the roots is where it cuts the x-axis, so these are the roots. Now let's look at the phenomena of the graph that the behavior of the graph that when it's close to the roots. Now you notice that the sign changes, all right, this is negative to a positive, all right, and then this is a positive to a negative. This is a positive to a negative, and over here is negative to a negative. Now what can you say that the to the graph when it is close to the roots? So it changes sign, all right, over here this tree it changes sign, but this one it does not change sign. That means that when the graph, the points near to the roots, the graph may change its sign or may not. Now let's move on to the asymptote. Now look at this asymptote. The sign changes. This is from negative to positive, all right, and then this is from negative to a negative. It does not change sign over here. So likewise for asymptote, all right, when it is close to the asymptote, all right, to slightly less than the x value of the asymptote and slightly more than the x value of the asymptote, you find that the graph may or may not change sign. Now besides these points, all right, at the roots and at the points around the roots and points around the vertical asymptote, there is no way that the graph will change its sign. Look at this part. It's negative, it always remains negative, all right, to the left of the roots. And then when it's right to the roots, all right, right of this root, it always remains positive until it touches the next root, all right. So you can see that the graph does not change its sign unless it's around the asymptote or around its roots, all right. So with this property, we can solve a rational inequalities by this way, okay. Now first, you can rearrange it to one side. You want to find where are the roots of this asymptote of this function as well as the asymptote of this function. Over p. Now you bring this over, so this will be greater than 0. Now then you express it as a single fraction. Now then you go on to determine its roots and its asymptote. Now, how to determine its roots? Now this graph cuts the x-axis when the numerator is equals to 0. For the asymptote, for the vertical asymptote, you equate your denominator equals to 0. So g of x equals to 0 or p of x equals to 0. Now after that, you substitute suitable values of x in each of its, around its roots and around its asymptote to test the sign of the function. Alright, then from there you can solve this inequality. Now this is best explained if I show you through an example. Now look at this function. This is a rational inequality. So what do we need to do is you bring the 1 to the other side, you express it in as a single fraction. So you will have 2x squared minus x minus 19 over x squared plus 3x plus 2 minus 1 is greater than or equals to 0. Alright, then what will you have? This you can express this as a common denominator. So you have 2x squared minus x minus 19 minus x squared minus 3x minus 2 over x squared plus 3x plus 2 is greater than 0. Alright, then you simplify the numerator. What do you have? You have x squared minus 4x minus 21 over x squared plus 3x plus 2 equals to 0. And then we try to factorize the numerator. So we have x now into minus 7 plus 3, and we factorize the denominator because we want to determine its vertical asymptote. So this will have x plus 2 into x plus 1. Alright, is greater than or equals to 0. Now then we can draw the location of its asymptote and also its roots on the number line. So you have a number line. So one of the root is at 7. Now then you will have minus 3, minus 2 and minus 1. Now minus 2 and minus 1 are the vertical asymptote, the location of the vertical asymptote. Alright, this is the value of x. Alright, then 7 and minus 3 are the roots. Now so you substitute values, alright, in between. Alright, maybe we start off with here, alright, a value that is greater than 7. Let's say we put 1,000. You'll find that this is positive, over 1,000 plus 2 is positive, 1,000 plus 1 is positive, so this is positive. Now you substitute a value that is in between minus 1 and 7. So let's say if you put x is equals to 0. If x is equal to 0, this is negative, this is positive. Then what do you get? You get a negative. And then denominator is a positive. So a negative divided by a positive is negative. Alright, then you put minus 1.5 over here, alright, into this equation, this inequality. Now you put 1.5 here, you find that this is negative, this is positive. So the numerator is negative. Alright, the denominator, what do you get for your denominator? The denominator is negative as well, because this is minus 1.5, this is negative, and this is positive. So negative divided by negative, you get positive. Now, then you put a value in between minus 3 or any value that is in between minus 3 and minus 2. Let's say you put minus 2.5. Minus 2.5, this will be positive. This is negative. So the numerator is negative. Alright. Now, then what's happened to the denominator? Now the denominator, this part is negative as well. Then minus 2.5 plus 1 is negative itself. So this is positive. So a negative divided by a positive is negative. Alright. You put a value. Now next we move on to minus 3. You put a value that is smaller than minus 3. Let's say you put a minus 1,000. Alright. Then you can try to do this yourself and you'll find that this is a positive. Alright. So the graph is positive over at this region. It's below the x-axis at this region. Is less than 0. The graph is above the x-axis at this region and this region. Alright. It's below the x-axis at these two regions. Now you want the graph to be greater than 0. So your values of x, what will be your value of x? So x will take values here. Alright, because when x takes values in this interval, you find that your f of x is greater than 0 or equals to 0. Alright, so your values of x will be over here, x is greater than or equals to 7. And here is x is greater than minus 2 and greater than or equals to minus 2, smaller than or equals to minus 1. And x is smaller than or equals to minus 3. Now, it seems that you may think that this is the answer. This is not the answer yet. Now, if you look at it properly, can x take the value of 2 or minus 2? No, because this is an asymptote. Can x take the value of minus 1? No, because this is an asymptote. So what must you do over here? You must take away the equal sign. Alright, so your values of x will then be minus 2. X is greater than minus 2, smaller than minus 1, and x is greater than minus 7, and x is smaller than or equals to minus 3. Okay, so this is your answer. Next, we come to modulus inequality. Now, you learn in secondary 4 or sec 3. Mod of x is equal to x when x is greater than 0 and minus x if x is less than 0. Now, in the same way, what do you mean by this inequality? Mod of f of x is smaller than a. Now, modulus means when the value is positive, or it will take on that value itself. However, when it is negative, you take the positive value of it. That means, let's say when x is 2, mod of 2 is 2. When x is minus 2, alright, the value of mod x is still 2 because minus 2 it becomes 2. Now, what does this mean? Now, if you look at a graph, this is the graph of f of x. Now, let's sketch the graph of mod f of x. So, you learn in sec 4, when this is the negative value of f of x, you reflect it about its x-axis. So your graph will look something like this. I draw it in dotted. Alright, so this whole graph here, this part, alright, is mod f of x. Alright, this thing is mod f of x. Mod f of x. So it's the one, the blue dotted one, as well as this, the upper, the one above the x-axis, the green one that is above the x-axis. Now, you want this mod f of x to be less than a. Now, let's say this is a, all right? You want the mod f of x, all right, this graph, to be less than a, all right? So, less than a, you want it to be less than this value. So, it is these values of x that you take, all right? Now, but if you consider f of x instead of this graph, all right, then let me draw the line y equals to minus a first. All right. Now you want this portion of the graph, all right, mod f of x to be smaller than a. So you want this portion of the graph, okay? This portion here. Okay. Now that means this is for the graph mod f of x. But if you unmod it, all right, so f of x, it is this part of the graph that you want for f of x. This one in red. All right. Correct. So that when you reflect it, all right, it becomes this part. So this inequalities means f of x is between a and minus a. Okay. This is something very important, all right, but you will be using a lot of it. Now, what is mod f of x is greater than a? What does it mean? Now, this one means f of x is greater than a, or f of x is smaller than minus a. Now, you look at it, okay? Now, you want f of x to be greater than a. So, it is this part of the graph that you want. Okay, maybe I draw it, this one in red. It is this part that you want. And this part. In terms of mod f of x. Now, if you unmod it, all right, you look at this graph now. Which part of the graph that you want? It is the one that is in blue, okay? It is now this part of the graph that you want. If you consider f of x. Okay? So, that's why your inequalities is like that, okay? Understand? So, this part is f of x is smaller than minus a. This part, f of x is greater than a. That's why you got this inequality. Now let's do an example. Now, by sketching appropriate graph, all right, sketching, by sketching. So it should be sketching appropriate graphs, solve this. Now, if you just blindly do this sum by this way, x minus 2 is greater than plus minus 2x minus 2. You may not get the answer, alright? I'm not too sure about this because if you do it this way, sometimes you get an answer, sometimes you do not get the answer. Why? Because when you do this, you are not sure whether 2x minus 2 is positive or negative, okay? Because if it's negative, you must flip the sign, okay? So you are not sure because it's a modulus, okay? It's a modulus. Now I will not go into detail. You can try on your own, okay? So some of you might, in Sec 4 might just do it blindly, all right? I always tell my students, no, you try to do it with the help of a graph, all right? You can also do it algebraically, but sometimes it's quite hard for you all to visualize. So I rather you all do it by the help of sketching a graph. All right, let's sketch this graph x minus 2 first. So it cuts the x-axis at minus 2, our y-axis at minus 2, the y-intercept is minus 2, and it has a gradient of 1. So this part must be 2. So this is your graph, okay? Now you mod it, so you actually reflect it about the x-axis for those parts that are below the x-axis. Okay, so let's say this is 2. So you reflect, your graph will look something like this. Okay, so this is y is equals to x minus 2. This part is y is equals to minus x plus 2. Alright, now you draw this graph. This graph also has a y intercept of minus 2, but now the gradient here is steeper. Alright, so this part is, this gradient is 2, so this it should cut at 1. So maybe I use blue or I use green. So this is your graph. Okay, so this graph is y is equals to 2x minus 2. Okay. Now if you look at it, you want this modulus graph to be greater than this graph. Alright. So this is the part that you want, because this part of the pink graph is higher than, is above this part of the green graph. Alright, because you want this part to be greater than this. Okay, so what are the values of x that you want? So your values of x, it will be, you will take this value, okay, until the point of intersect, the x value of the point of intersection. Okay, so what we can do is we can find the value, the x value of this intersection point. How to find the x value of this intersection point? You simply equate this graph to this graph, all right, because this is the intersection of the point. So you have minus x plus 2 is equals to 2x minus 2. And then you bring your x over, you have 3x is equals to 4. And x is equals to 4 over 3. Now you want the value of x to be less than 4 over 3. All right, so you have an equal sign here as well. So x will be less than or equals to 4 over 3. So this is your answer to this inequality. Now, thank you.